Last unit, we talked about rational expressions as being fractions where there are variables in the denominator, because that makes for certain situations. And last unit, we add, subtract, and multiply, divide, right? Keep, change, flip, and all that kind of stuff. And then this unit, what we did was throw in equations to the mix, so equaling something else, and then we're solving for the variables. Our lesson from Friday, if you can remember, we talked about excluded values. We talked, remember it was the note page with the pizza in the middle that looked maybe like it could have been a chocolate chip cookie or something that day. We talked about how when there's a variable in the bottom, well, first of all, we talked about how you can't take a pizza and divide it into 0. And same thing for fractions. You can't divide by 0. It's called undefined. And so then we spent the rest of that day, wherever there was a variable in the denominator, we figured out, well, what number would make that equal to 0? Like, for example, here in this problem, what number would make this denominator 0 if I plugged it in for r? -3. If I plugged in -3, it would make the bottom 0. And so we call that excluded values, okay? And we're going to do that today. We're going to find the excluded values. But then we're going to actually solve these equations and double check that they're good. If we happen to get a solution that is an excluded value, we'd have to say that one doesn't count because we had to exclude it. Do you want me to say exclude one more time? I feel like I could. Exclude, 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 exclude. Yeah, I feel like I said it like 1,000 times. So here's our goal for today. Solving proportions. These are rational equations, but they're a specific kind. Tomorrow we're going to solve a different kind. So here's what rational equations look like when you can solve using today's method. It'll look something like this. You will have, some stuff over some other stuff equaling to some stuff over some other stuff. Okay? But here's what it does not look like. Today's method cannot be used in situations like this. Again. What's the difference between the, what do you think is the difference that makes the method work for the top one but not the second one? What's going on that's different? One has a subtraction in it. If there's addition or subtraction in the equation, today's method won't work. And tomorrow's, what we're going to do tomorrow will address that. So just keep this in mind as we go through the rest of the unit. We're learning 2 different methods. They apply in different situations. You can if they have common denominators. But if not, then you have to talk about what to do next. And we'll do that tomorrow. So that's what a proportion is. When it happens, so I thought I was clever writing this. It's the what, when, where, why, and how. I thought that was clever when I was making this. Right now, it seems kind of annoying, but anyway, I already made the copies, so we're going with it. When I don't know. I just don't know what goes on in my brain sometimes. Okay. So when does this happen? This happens when 2 fractions are equal. That's what a proportion is. And the kind of fractions we're dealing with specifically are rational expressions, where there are variables in the denominator. So this method is when you have 2 fractions that are equal with no adding or subtracting any other fractions anywhere. And where does this happen? This is where I'm sorry, I have to do this. It happens here in all these example problems. So stupid. Okay. Huh? Yeah, they are. They're doing them. why do we have this method? It's to help us solve faster. And I'm going to show you what I mean. So a lot of times what happens when we have methods that look like shortcuts, what happens is we forget that there's actually math behind it. And we'll go to a problem like in the future and be like, the butterfly thing, I remember, when are we supposed to do that? So I want to tell you why this method is a thing in the first place. If you have some kind of proportion like this, and you weren't solving, like using the butterfly or cross method thing, you might do this. You might think, oh, okay, I know what to do when there's a denominator. I multiply both sides by that number to get rid of it. And so you might do the denominators one at a time. You might say, okay, let's do this times 5 here, and this times 5, because these would cancel. And then I would have 15x over 7 equals 6. And then you would say, I still have another denominator. So now I'm going to multiply both of those sides by that 7 to get rid of it. And so then that would give you 15x equals 6. And then now you can divide both sides by 15. Oh, yeah, you don't. I knew I was doing something wrong. I was like, I just feel like something's going wrong here. I felt it in my bones, but I couldn't figure out what it was. You don't cross out the 7. You get 15x equals 42. And then you divide by 15. And then you can simplify that fraction if you were trying to be serious about everything. Dividing by 3, you have 14/5. But what this method today does for proportions only is it saves you some work. Basically what we're going to do is multiply both sides by 5 and both sides by 7 at the same time by doing this. So here's the original equation. And we're going to do this. We're taking what's called the cross products. The butterfly. Okay, so you can call this cross multiply. You can remember butterfly. And so then once you take those cross products, you get 15x equals 42. And that's faster than, see, I got to 15x equals 42 there as well, but it just took me a few more steps. Yeah. So then, simplifying your fraction, you get the same thing, 14 fifths. So that's why we have this method. The only downside to remembering this as a shortcut is students try and do it when they're not working with equations. And I don't want you to write this down, but just to look with your eyeballs. Like whenever we're in the last unit, when we're multiplying rational expressions, like if I gave you this and I was trying to get you to cancel, right, factors, what they had in common, I see students do this. Because they just see two fractions and their memory tells them, hey, cross multiply. That's problems with shortcuts, is that you oftentimes can't remember the context for the situation. And the context here is that it's an equation, two fractions equal, whereas over here from last unit, this is two fractions being multiplied. So that's the difference. So we're going to do some examples. There was no question, right? You were just talking. Okay. So going back up to the top. So the first thing we want to do, though, is figure out what our excluded values are. Because when we find our solution, we want to make sure it will not make the denominator 0. So looking at this denominator here, before we even do our cross multiply, what would make that equal to 0? What value of r would make that 0? This one right here. -3. So that's an excluded value. So excluded value, r cannot equal -3. We have to figure that out before we even start solving so we can check ourselves. What, did I write something wrong? That's from Friday's lesson. Oh, this one was just an example of the method, and I didn't have x's in the bottom. Just numbers in the bottom, it can never equal 0 because it will always just be 7 or always just be 5. Once you put a variable in the bottom, though, now you have a special circumstance that you have to watch out for, because different things can go in for x, and you have to find the thing that would make it 0. But without an x, it's good. But here, this one has a variable in the bottom, so we have to say, okay, in what case would it be 0? Well, if the case is when r is -3. And the reason why we have to point that out to ourselves is because if we do the math and we solve and we get 3, then it's a fake solution. It's what we call extraneous, and we would say, oh, okay, look, there's no solution at all, actually. But no, that's not going to happen on this one, though. So sort of like pre-work, this is our pre-work. Figure out what r cannot equal, and then now we do the actual solving. We do our cross-multiplying. So that gives me r times 1, which is just r. And then it's 4 times all of r plus 3. So guess what I'm going to put? 4r plus 12, parentheses, right? 4 times all of r plus 3. And then, yes, like Drake yawned, it'll be 4r plus 12. And that's just a little vanilla equation to solve. What would you do to both sides? Get the r's on one side. Do you want to move this to the left or that? This to the right or that to the left? 4? Okay. So that gives me -3r equals 12. Then what? Divide by -3. R equals -4. Is it okay for r to equal -4? Yes. So that's our solution. It can't be -3, but -4, it can be -4 all day long. So you try the next one. And I'm going to enter attendance while on this one. I should have talked about the excluded value on this just to refresh your brain. So the excluded value, when we did this lesson Friday, which feels really like a long time ago, what we did was if there's no variable on the bottom, like with the 8, that's okay. There's no excluded value there because it will always be 8. It could never be 0, so it's safe. But this one, when there's a variable in the bottom, that's the one we have to check out. And what we did Friday was set it equal to 0 and then solve it. So you would just solve it like a regular little equation. You add your 6 to both sides, divide by 5. So r cannot be 6/5. So if we get 6/5 for an answer, we have to exclude it, right? It wouldn't actually work. It'd be a false solution. It'd be extraneous. Yes, only when there's a variable. Yeah, there can be 2 excluded values. There can be as many excluded values as there are denominators, and then sometimes you even have to factor denominators, and there could be multiple ones. So that's just your pre-work, just finding the excluded values. So then you start the actual solution or solving process by cross-multiplying. And then this one is a little bit different, but still kind of the same. So 8 times r minus 8, don't forget your parentheses, because it's that entire group that's getting multiplied by the 8. And then 5 times 5r minus 6. Those are distributive properties. So if you haven't, go ahead and you distribute yours. I'll distribute mine. But don't look at mine till you do yours, because then you can't unsee what you've seen and you think you understand when maybe you don't. In last period, saw this and they were all like, what? And y'all know what to do on this, right? It's just a two-step equation. You get all your variables on one side and your numbers on the other. You haven't seen it in a while, but you know it's in there. It's in there. So you have to get the r's on one side and the constants on the other, right? It's a two-step equation. So which r's do you want to move? To the left or to the right? To the right. Okay, I heard that first. I heard right first. So then I need to move this r over that way by doing the opposite. What is going on? That lag time is going to drive me crazy. So if I move the r's to the right, then I need to do what with the constant? Move it to the left. So I would do that by adding 30. And now on the left-hand side, the r's cancel, leaving me negative 34. And on the right-hand side, the 30s cancel, leaving me 17r. I feel like a pirate with all these r's. And then, so now you have your variables on one side, your number on the other. What do you do? Divide. Divide by 17. I'm running out of room. So r equals negative 2. Is that okay? Are we good with that? Can it be negative 2? Yes, because that's not my excluded value. So, winner, winner, chicken dinner. Are we going to have to multiply variables what? Yes. Not in the notes, but on the practice problems we do. Yeah. All right, you try number 3. The second denominator is actually really easy, but so easy that then sometimes students doubt themselves, like it can't be that easy. What number that you would put in for v would make this 0? 0, right? So v, for that right side, v cannot be 0. And then on the left side, you just make yourself your tiny little equation. You set it equal to 0, add 2 to both sides, and then divide by 3. So it can't be 2/3, and it can't be 0. So now do your solving and making sure none of your solutions are that. Blah, 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 blah. Cross multiply here. Cross multiply here. You should have 20v. And I'll skip the distributive step. So it's 7 times all of that. So you have 21v minus 14. Yes? Then what did you do? Move the 14 over. And if you're going to do that, then you have to move the 20v over. So 14 equals v. Is that okay? Is that one of my excluded values? Nope. So it's good. What are the excluded values on number 4? Boom. There are none. Because there's no what's in the bottoms. Yeah, there's no variables. So the bottoms can never equal 0. This one will always be 8 forever. And this one will always be 3 forever. So it can never be 0. So excluded values, none. Have you already worked that one too? So we can do it real fast. That one real fast. Did you get 3/2? Excellent. Years of practice. My stepmom. So, yeah. What did you do to to both sides here? Cross multiply. One thing about cross multiplying here, your r plus 2 times your r plus 10, that's going to be a FOIL thing, okay? So it's not just the r's being multiplied and just the 2 and the 10. It's all of the one times all of the other. And when you write it out like this, like don't try and just think about it in your head, but actually like when you see it written like this, it's clear. It's like, oh, okay, that's a FOIL. And then you want to do this. Take a minute. If you haven't already, just do that. And then we'll regroup and talk about what to do next if you're uncomfortable with it. These are easy, right? The one on the left cannot be 8. The one on the right can't be 10. So r can't be negative 8. Positive 8, and r can't be negative 10. I have this. Did you get that? Because I make mistakes quite often. Yes. Something cancels right now. What is it? The r squareds, because they're the same on both sides. So we can just get rid of them. Boom, boom. So now I have 12r plus 20 equals negative 8r. What you want to do? Gus? Okay. So that gives me 20 equals negative 20r. Yep. By negative 20, right? So r equals negative 1. Was that one of my excluded values? No? So we're good to go. It is amazing.